feel free to chime in.
Sorry, Deanna, what was that? Deanna, what was that?
No, I said, Cole, feel free to chime in if you have questions or if you know the answer. And even if you are not sure, we welcome the conversation.
Yeah, absolutely.
Awesome.
And again, this is all recorded and everything like that. So if you ever want to rewatch it, you can. So it's all put out here in our course under the online math resources for students.
Okay.
So if you go in here and you click on our course for stats, hopefully you all have seen this because you're enrolled in this course.
Mm-hmm.
So all of our testing information is right here.
Okay.
Okay.
Sounds good.
So at the end of this video, the video will be posted out here. Here is the blank version. We're working on the answer key for it right now. So all that will be posted once we're done.
Sounds good.
Okay. Well, let's do this. And I do have StatCrunch opened. I also have the TI-84 opened because you should have access to both of these. But generally, when it comes to your test, my advice to you is use StatCrunch. It is the more bang for your buck. It has more features, a little bit more user friendly as well too.
Gotcha. So. Should I grab? I have a TI Inspire. Should I grab that real fast?
If you want, it's purely up to you.
Okay, I'll go grab that. I apologize.
No worries. All right, you ready, Cole?
Yes, I am.
I think we have a new one. Miriam. Hi, Miriam. Okay, so test 2, exam 2 covers chapters 4 and 6. Chapter 4 is all about basically linear regression lines for us. And then chapter 6 was all about sampling distributions, or basically overall the normal distribution. Okay. So over here, it says the figure shows a scatter plot of the age of students and the value of their cars. Does it show an increasing trend, decreasing trend, a changing trend, or very little trend? What kind of trend is this?
I think
it is changing, you bet, because it decreases, then increases. So that's definitely a changing trend. And sometimes I'm going to have some pause because I'm writing down the answers to this for the answer key. Okay. All right. So over here, again, in your guys' exam, these will be drop down because they're just asking you about 3 pieces that you're going to put in here. Okay. So in these blanks, the choices are right beside it. So it says the figure shows a scatter plot of shoe size and GPA for some students. Does it show an increasing trend, a decreasing trend, or no trend? Is there a strong relationship? So what do you think?
No trend.
No trend.
Yeah, definitely no trend. Is there a strong relationship then?
No.
No. All right. So the graph shows blank, a decreasing, increasing, or no?
No linear.
No.
There we go. Okay. So the first answer is no linear trend, since the points show blank, a decreasing, an increasing, or no pattern.
No pattern.
Yepers. By scanning the graph from left to right, the relationship blank is or is not strong.
Is not.
Is not.
Oh, good. You don't even need me. Is not strong because the points blank do not show or show consistent and small vertical spread.
I'm not sure.
Do not.
Yeah, this one is going to be a do not show the consistent and small vertical spread. And so what they're getting at there is basically it does not show a line. That's what they're saying. You know, not an increasing line, not a decreasing line. So do not show. Does that make sense?
Mm-hmm.
Yes.
Yeah, sometimes the wording is catchy. So you got to make sure that you read very, very carefully, especially in stats. All right. So part 3, we got 2 parts to this. It actually continues on to the next page. So the scatter plot shows the number of hours of work per week and the number of hours of sleep per night for some college students. So part A, does the graph show an increasing trend, decreasing trend, very little trend? Which one is it?
Very little trend.
Yeah, very little trend. So that would be B. Sorry about that. I wrote down the wrong letter. Okay. So then part B.
Brandon, you're recording, right?
I am recording.
Okay.
Okay, so it says explain. So we said it shows very little trend. Which one of these is the explanation for that very little trend?
I'd say A.
Yeah, absolutely. That's what I would go with because it's not showing a relationship because those dots are not showing a pattern.
Mm-hmm.
You know, it's just like, let's make dots on a graph and call this, this, and this. So I like it. So we would select A, the number of hours of work does not seem to be related to the number of hours of sleep for these students. Okay. Moving on. And all these questions right here, these are all coming from 4.1, just so you know. So these are chapter 4, and they're all coming from 4.1 right now. Okay. I'll let you know when we switch up, but just like the last exam, the exam goes in order of everything that you guys discussed throughout. You know, it's not going to jump around or anything like that. Okay. So question number 4. The figure shows a scatter plot of birth rate, so live births per 1,000 women, and the age of the mother in the United States. Would it make sense to find a correlation for this data? Explain. So according to this graph, at approximately what age does the highest fertility rate occur? So Deanna, I feel like we're missing a question here. Because it seems like there's an extra question right here. According to this graph, at approximately what age does the highest fertility rate occur? So there's 2 separate questions, but there's only one down here. Check on that for me.
Okay, I'm going to check.
Okay. So would it make sense to find a correlation for this data?
Yes.
Yes. Why?
Because there's a trend
What's the trend?
changing. Well, actually, would it be B because both are
Not
numerical?
linear.
You got to be careful though. Yes, you can kind of see that changing trend, but do we like changing trends?
So it'd be numerical.
No, it's not numerical. I would. The answer to this is a no.
Wow.
We don't want to do this one. Why?
It's not linear.
It's not linear. So keep that in mind, Cole. Even though, yes, you see that changing trend there, we don't like changing trends. We want linear, 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 linear. That's a big push in section 4. Even though you might see, a pattern, if it's not linear, we don't care.
Gotcha.
Okay.
So then it would be D.
Yes. No. It would not make sense to find the correlation because the trend is not linear.
So if it's not linear, then there's never going to be a correlation?
I'm not saying that. Okay. It's just that we don't really care about it.
Gotcha.
It's a little bit above our pay grade at this moment in time. Does that make sense?
Gotcha. Yes, sir.
Because there are trends. I mean, this thing looks very much quadratic in nature. So, I mean, there are trends and there are regressions that we can map onto this. But for us, as statisticians, for what we're doing right now, it's linear only. Linear or nothing. Now, keep in mind what we said right here. We're going to go ahead and answer this second question here, even though it's probably supposed to be up here. I think it just got omitted by accident. So according to this graph, at approximately what age does the highest fertility rate occur?
28.
Yeah, probably somewhere around 28, right? But without seeing what they put down there, my gut is telling me, and just because of what I know about this, if we're going to say that it doesn't make sense to find a correlation because it's not linear, then my gut is saying that there's a selection down here that's going to say this doesn't make sense to find the highest fertility rate because it's not linear. Does that make sense?
So if it were multiple choice, just look for that.
Yeah. If you say that there is not a linear trend here, then there's no point in answering this question. Does that make sense?
Right.
If it was linear, then yes, let's answer that question. So in this one, my gut is telling me, even though we could kind of look at this and say, oh, the mother's age is probably 28, without actually having those multiple choice, because again, they make everything multiple choice for you in here. I would say this is one of those pieces where it doesn't make sense to do that since it's not linear. Okay. And Deanna will get back to us and she'll let us know. I'm pretty sure there's an answer that goes along with what I just said.
I didn't find it in the material,
Interesting.
but I seen that question in the homework was exactly that second part. So I wonder if on the test it's not required or if it was just an accident.
But I know you've been working on this too, Deanna. Wouldn't you agree with what I just said though? That because it's not linear, we wouldn't care about this question.
Right, and that's probably the reason why it was omitted, because the data is not linear.
Yeah. Okay. That's a good point too. That could be why we don't have that second question. All right. So question 5. We just want to know which one of these, okay, and that last question, that was definitely still 4.2. So question 5 or 4.1. So question 5 actually begins 4.2. Okay. So we want to know which one of these it has that correlation coefficient of negative 0.9, 0.64, and 0.0. The easy one to start with, I would begin with one of these two outside ones. Because what do we know about that correlation coefficient?
That the closer to 1, the closer to a perfect line.
Yes. The closer to 1 or a -1, the more your line looks like a straight line. What happens when you're close to 0?
It's going to be scattered all over the place.
Scattered all over the place. That's why I would usually start with these instead of the intermediate number that's kind of right here. I always start with the numbers that are closest to 1 or -1, and then also the ones that are closest to 0. So obviously, graph number 1 right here, is it A, B, or C?
I'd say graph number 1 is C.
Definitely. Because when you are 0, you're scattered all over the place, just like what you told me, Cole. Good job.
Thank you.
Okay. So now we've got these two left. Let's talk about graph 3. See how this has definitely got that negative trend? And when you have a negative trend, that's also another key for you up here. If any of these numbers are negative, that means you have a negative slope. Okay? This is the only one with a negative slope. This is the only number with a negative. Plus, if you look at the number, it's close to -1, right?
Mm-hmm.
So it should look like a line.
Right.
This is the one, graph number 3, that looks like a line. So is that A or B?
Graph number 3 is going to be A.
You got it. And then by process of elimination, we know that B has to be graph 2.
Mm-hmm.
Any questions on number 5?
Mm-mm.
No.
All righty. Okay. So, number 6, still in 4-2. Okay. So they've given us the equation right here. So they want us to answer some questions about the mother's height and the daughter's height. So part A says, as the data are graphed, which is the independent and which is the dependent? So the independent, is it the mother's height or the daughter's height?
Would the mother's height be independent?
You got it. X-axis is independent. Then that means in the next one, the dependent variable is?
Daughter's height.
Yepers. Okay. Part B. So from the graph, approximately predict the height of the daughter of a mother who is 65 inches. Okay.
Mm-hmm.
So go out to 65. We're right here. What is the approximate height of the daughter?
65.
Probably 65. Maybe, yeah. I'd go with 65.
Mm-hmm.
And again, this is the tough part because we're kind of, guessing from the graph. 65, could be a little bit higher. I can't quite tell. But, I definitely say 65. Okay. And it says round to the nearest inch. So that means they just don't want any decimals. So I definitely go with 65. Part C is for us to kind of verify that. So part C, they just want us to use the equation. Okay.
Mm-hmm.
So give me just a moment to write this equation down. 0.5777 mother. All right. So all they want you to do in this one is plug in 0.5777 times 65. So we plugged in the 65, and all this is just calculator work. So go to your fancy calculator. 27. Actually, I'll let you guys do this. You know how to plug in. Go to that calculator. and tell me what we get. And the rounding, it says, round to 2 decimal places. How tall is the daughter?
You want 2 decimal places?
Mm-hmm.
65.34.
See, we were darn close. Okay. Any questions so far on that part? I'm just going to double check you guys real quick on my calculator. Just on the rounding part, because I know sometimes rounding kicks our booty. Yep, 65.34. Love it. Okay. And in part D and E, lots of things on this one. Okay, part D says interpret the slope. Now this is big, and this is where in my videos that I put out for my students, I know I talked very, very carefully about the slope, because the slope is all about the average of the Y value when we increase by 1 unit for the X value. It's really, really, it's an interesting phrase, because it is the average Y value when you increase by 1 unit. Okay. So up here, here's our slope, 0.5777. So what does that mean? Too far down.
I would say it's either C or D.
You are correct. It is either C or D.
And it looks like C is going to be the answer.
You are on it.
Sweet.
Okay.
Although I kind of got that from looking at the graph. Could you explain how you would have gotten that if there was no graph?
They would have to tell you.
Gotcha. Okay.
They would have to tell you. And up here, even if there was no graph, you would know that the mother is independent.
Right.
The daughter is dependent. So, I mean.
Oh, because the equation is the daughter and the
the daughter is the Y value.
Marginal height would be 0.577.
Uh-huh. Yeah. Cool. Yeah, because remember, this is always the independent over here next to the slope. Mm-hmm. The dependent is always what it's equal to.
Okay, thank you.
Because the daughter depends on the mother. Mm-hmm. But you are correct with C, because right here, this is the part that I was talking about for the X. Right. Whenever we add 1 inch in mother's height, the average daughter's height increases by that slope. Okay?
Yes, sir.
Good job.
Thank you.
So I just got to write this down. Additional inch. And then you can go ahead and take a look at E while I'm doing some quick writing. So it says, what other factors besides mother's height might influence the daughter's height? Give me just a second to write. But again, it says select all.
The father's height.
The father's height, absolutely.
And the daughter's nutrition.
The daughter's nutrition. Okay.
That's it.
I agree. Both of those would affect. And there are lots of other ones too. Average. Still writing part D down real quick. But you guys got it. Average daughters.
We had exactly the same homework.
Huh?
That was the same homework, exactly.
Yeah. Usually what happens in this one is that they change the equation.
Just the equation, yeah.
Mm-hmm. Yeah, so just keep an eye on things like that. They do minor modifications. About 0.577 inch. All right, and then part E, you guys got it. You said A, father's height. Sorry, I'm so slow. And D, daughter's nutrition. All right. Perfect. All right. Number 7. So again, lots of information that's down below here. So it says measurements were made for a sample of adult men. Assume the association between hand length and foot length is linear. So they're telling us to assume this, although it's not always good to assume. The output for predicting foot length from hand length is provided from several different statistical technologies. Okay? So we got lots of different pieces here. So here's the TI-84. This, I believe, I think this one's Excel. This is StatCrunch, and I believe this one is Minitab. Okay. So first things first, part A, they want us to report the equation. So they want us to give the equation here. Okay.
Mhm.
So is this first blank predicted hand or predicted foot?
Should be predicted foot.
Yeah, absolutely. Look at your equations here. See, it says foot equals.
Mhm.
Foot equals. And then the other ones don't tell you. So use that information to your advantage. So definitely predicted foot L equals, what's this?
9.3.
9.3. Okay, and it actually says to round to 3 decimal places. So we might want to look at some of these other ones, like right here. So this will be more informative for us. Does that make sense? So not 9.3, but it says 3 decimal places. So 9 point what?
2889.
2
289.
289. You got it. Plus, what is our next number?
0.925.
Yay.
And
And then the last one, is it hand or foot?
and
Yay. There you go. Now we have our equation. Okay? So if you didn't get that equation when we were talking about it, it's right there. Predicted foot L equals 9.289 plus 0.925 hand L. All right, part B. So again, part B goes to explain how to find the slope and the intercept for each display output. So which one of these is how we find that slope and intercept?
Well, the slope's not constant, so it's not going to be A or C.
You got it.
D.
Say it again.
D.
Yeah, right here. The slope is the number multiplied by hand L, which you can see that in both of these. Slope, hand L. Slope, hand L. Okay. And then the intercept is the one that's the constant. Yeah. You guys are good. So we've got D for the answer. The slope is the number being multiplied by hand L, and the intercept is the constant. I like how you guys are reasoning some of these answers out loud, saying, well, we know it can't be this.
Mhm.
That's always helpful. Narrow down your options. All right, explain how to find the slope and the intercept for the displayed output. So, okay. So I think this one was for the top one. And I think part C is for the actual stack crunch. So part B, I think that was for the mini tab. And then part C for the stack crunch. All right. So how can we find the slope and the intercept from this displayed output?
A.
You got it.
Yeah.
Yep. It's just all about that equation again. So pretty much the same answer, other than the fact that they say in the fourth line. The slope is multiplied by hand L, and the intercept is the constant. All right, part D. Again, we got another display. All right, they're asking, how do we find the slope and the intercept from this? I don't think there is a part E. So how do we find the slope and the intercept based off of that display?
Would it be A?
The slope is the x variable value and the intercept is the intercept. Yeah, absolutely. Yepers. Slope is the x variable value and the intercept is the intercept value. Right on, right on. All they're really testing you is, do you know how to read the information? All right, so part E. How do we find the slope and the intercept for this one?
Would it be D?
It is D. Because this is the way that statisticians write it. So this A represents, like, if you think about this like y equals mx plus b, the m is the b, and the A is the actual b from the mx plus b part.
Right.
So it's just written backwards. That's all it is. So D is correct. The A value is the intercept. And the B value is the slope. Perfecto. Still in 4-2, just so you know. Number 8. So taking a look, I think this one is where we jump into 4-3. Double checking some things real quick. No, not yet. All right. So right here, still in 4-2. So it says that the equation for the regression line relating the salary and the year first employed is given. Okay, so that equation's right up here at the top. Okay. Yeah, we're still in 4-2 because they're asking us about the slope and the intercept to interpret. So the question A says, interpret the slope. What does it mean? Which one of these is it?
Is it A?
It is A. Yeah. Because again, remember the slope is all about that average Y value. So this says the average salary, which salary is all about the Y value. And because it's subtraction here, that means it's going down.
Mhm.
Is less for each year, which represents the year that we keep moving up. So that's moving up by 1 unit. So it definitely meets it, part A. So the average salary is $2,099 less for each year later. That the person was hired or an average of 2,099 for each year earlier. Okay. Part B, what does the y-intercept mean? And is it appropriate? Because the y-intercept is the one that you got to make sure that, is this really appropriate to talk about?
I think, let's see. Would it be, it's either C or B, is that right?
Okay.
Um,
B would not make any sense. No.
is it C?
It is C. When you think about the y-intercept, that means your x value is always 0.
Mhm.
Okay. So up here, know that 1985 is not where this graph starts. It starts all the way back here at 0. So there's all these years before it. Okay. The
Mhm.
y-intercept is always about what happens at year 0. So at year 0, that means people were making $4,255,424. Yeah.
Right.
Would be making that much. And does that make sense?
Yeah, absolutely.
Yeah. At year 0, that makes sense. I would be making.
No, I meant you made sense what you were saying.
Oh, okay. I got what you said. Oh, yeah. I'm like, man, I wish. I'm going to go back to year 0 now.
Yeah, I wish, right? Minus the inflation, that'd be great.
Yeah. Yeah. So, I mean, again, when you think about that intercept, think about it in terms of x is 0. Here's the y value for that. The average y value be that.
Right.
Because this is always about the average. Year 0, which is not appropriate to interpret. Okay. Moving on. So question number 9. So we've got this information. Data were collected that included information on the weight of trash in pounds. Okay. On the street 1 week, the number of people, let me read that. The information on the weight of the trash in pounds on the street 1 week, the number of people who lived in the, I think that meant to be like compared with the number of people who lived in the house. So we've got this. We've got our equation here because it's definitely got a little bit of linear action going on. So part A, again, still in 4-2. Is the trend positive or negative?
Positive.
Okay, so our first blank is the word positive. Okay, as the number of people per household increases, the weight of the trash does not tend to change, tends to increase, tends to decrease.
Tends to increase.
You got it. So as the people increase, the trash increases, which makes sense. More people, more trash. All right. Part B says calculate the correlation between the weight of trash and the number of people. Okay, so they want us to find the correlation coefficient. All right, so in order to do that, there's a formula to find the correlation coefficient. And that formula is really, really gross. Deanna, do we have any data for this?
It says
there it
R
is.
equals
All right.
something on the graph.
Yeah. Never mind. So we've got use the R square from the figure and take the square root. So there's the hint for us. All we have to do is come up here, take this little figure, this R squared, and take the square root of that. But be careful, that's a percentage. So what are we really taking the square root of?
A decimal.
A decimal. So 0.876. Take the square root of 0.876 and tell us what it is to 2 decimal places.
88.
Say it again.
0.88.
0.88. Okay.
I think it's 0.94.
Ooh, we got contending pieces of information.
Oh,
It is
never mind.
0.94.
Oh,
So 0.94. Because you go into your calculator, you hit second square root 0.876. Does that make sense, Miriam?
oh, okay. I got it now.
Okay.
Over here.
All right. So now it says part C, let's report the slope and basically interpret it. Okay. So the slope is what?
Is it 9.58?
Okay. So there's our first blank. So the slope is 9.58. For each additional person in the house, there are, on average, blank additional pounds of trash. What goes in the second blank?
The first number.
Yeah, the first number again. 9.58. Because as we add a person, the pounds of trash should go up 9.58 pounds on average. All right, D. D says interpret the intercept, okay? And explain why it is not appropriate, or explain why it is not appropriate to interpret. All right, so what is our intercept?
7.18.
And what does that mean?
That's at 0.
So 0 what?
0 people. So
If I have 0 people in a house, there's 7.148 pounds of trash.
yeah, it wouldn't make sense.
Okay. So which one would we choose then? A, B, C, or D?
It is inappropriate to interpret the intercept because it does not make sense to think a household with 0 people of generating trash.
Correct. Just writing this down. All righty. Moving on from there. And if I remember right, this is not a very long test. I think it's only 20 questions. So I think we're about halfway through. Let me double check. Yeah, 20 questions. Cool. All right. So jumping back up too far. Okay. So now we are going to be jumping to. Interesting. Okay. So now, I mean, basically 4.1 and 4.2, and some of those concepts that we talked about up above, they were covered in 4.3, but most of the information comes from 4.1, 4.2. But now we're going to jump into chapter 6. So question 10 starts chapter 6. So this is definitely coming from 6.1. And I'll go back through in my answer key and modify that some so I can tell you exactly where each one of those problems were coming from. But most of them were 4.1, 4.2, and 4.3. Very little 4.4, if any. So here, they just want to know, is this continuous or is this discrete? Remember, continuous means that it's like a range of data. So think like I can have multiple decimals. Discrete is kind of like we can count them, like hard, fast numbers, like 1, 2, 3, 4, things like that. So
I'd say discrete then.
For part A?
Yeah.
So the number of people you have dated in the past year. Absolutely. You're not going to have any, you can't say I dated 3.5 people. What do you mean 0.5 of a date?
Right.
Either you dated them or you didn't. So that's definitely discrete. Perfect. The random variable is discrete. Okay, and then part B is the decibel level of a siren, discrete or continuous.
Continuous.
Definitely continuous, which is talking about the sound. The sound can vary in size. So that's definitely continuous. Perfect. So you can see there's really not a lot of math on here.
Mm-hmm.
All right. Oh, there's a C and a D to this. My bad. Do a quick erase here. All right. So the height of a tree, discrete or continuous?
Is that asking for the height of a type of tree or just a tree outside?
Any tree.
I want to say continuous.
Yeah, definitely continuous because you're going to have decimals in there, and those decimals can range. So definitely that is a B. The random variable is continuous. Okay. The number of mint condition baseball cards in a collection.
Discrete.
Sorry, say that again.
Discrete.
Yeah, definitely discrete. Either it's mint condition or it's not. There's no halfway there. So, and you can definitely count that up. Is discrete. Okay. So number 11, moving on. So a magician shaved an edge off one side of a six-sided die. As a result, the die is no longer fair. The figure shows a graph of the probability density. So we're missing that figure. The PDF in the table format, they want us to basically complete the table. We're going to have to come back to this one. Deanna, if you could see if you could find us that graph.
Okay, no problem.
Sorry, I'm just making the table real quick when we come back to it. Oops. Okay. Ah, that's horrible. Sorry, just give me a moment. Okay. So we're going to come back to that. Deanna's going to show us that picture because without the picture, we don't know. All right. So right here, number 12. So it says Eric wants to go skiing tomorrow, but only if there are 4 inches or more of snow. According to the weather report, oh, she's got it for us. Perfect. Let me open this picture up. Just thinking about life. There we go. There's our picture. So what is the probability of rolling 1?
0.6.
0.6? No, but close.
6%.
6%, which is 0.06. Okay. So make sure that you're careful with those decimals. It's 0.06.
0.6.
Okay. Who else shares that same probability?
6.
All right. So under the 6, you'll put 0.06. What is everybody else?
Point 22.
You got it.
Do they not want that in percentages?
We'll look at that in just 1 second. See what the directions say. So there are their probabilities. So remember the first and the last one, they were 0.06 and then everybody else was 0.22. So let's go back and let's take a look at that and see if it said percentages. It doesn't say anything about percentages, so I'd put it in as the decimal.
Okay.
Yeah, but definitely a good question. But and also the other thing is, if you're looking at your when you're looking at that table, everything was in the decimal version of it.
Mhm.
So if the table was in the percentage mode of it, I'd probably put in the percents. So
Gotcha.
look at your table, see what it's kind of in.
Okay.
Okay. All right. So back to this guy. So Eric's only going to go skiing if there's 4 more inches of new snow. So this is continuous. Okay. And remember, excuse me, continuous is about, like the area under the curve. Keep that in mind. So according to the weather report, any amount of new snow between 2 inches and 7 inches is equally likely. The probability density curve for tomorrow's new snow is shown. Shade the appropriate area and calculate its numerical value to find the probability. Remember, the total area under this thing is 1. So which one of these graphs represents 4 or more inches?
A.
You got it. And I'm going to kind of do a quick version of this graph. 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 7, 8. 0.2. From 2 to 7. Okay. So this is the graph you chose. Okay. So from 4 to 7, it was all shaded and it was up at 0.2. Okay. Now, the next question is going to be, what is the probability of that happening, if I remember correctly? Let me scroll down a little bit. Yep. So what's the probability? And it says to simplify your answer. I'm not sure why we would have that there. I assume it's going to want the decimal because it doesn't say anything about the percentage. Okay. So remember that this is about the area under the curve. Okay. What is this shape?
Of the shaded area?
Yeah.
Rectangle.
So if it's about the area under the curve, which this is our curve right here, how do you find the area of a rectangle?
For this question, is it 3 times 0.2?
It is. Because to find the area of a rectangle, you take the length times the width. And what's the length? 1, 2, 3. What's the width?
0.2.
0.2. It is 0.2, right? Not 0.2? Yeah, 0.2. So all we're going to do is take 3 times 0.2, and what do you get?
0.6.
0.6? Okay. And if we were thinking about this in terms of a percentage, if they wanted a percentage, what would that be?
6%.
60%. So, but I think they want the actual decimal version of it. So that's what we're going to keep. Okay. So that was part B right there. Oops. All right. Any questions on number 12? So the rest of this stuff is all going to come from 6.2 because we only had 2 sections in chapter 6, 6.1 and 6.2. Okay. Here we go. So 6.2, if you remember, it really talks about sampling distributions and the normal distribution. So, and it relates really back to the empirical rule. Okay. So 13, we've got a couple of questions about percentages here. So they want to know, what is the percentage between -2 and 2?
95%.
95.
You got it. So it's B, 95%. Okay. Roughly, what is the percentage of z-scores between -3 and 3?
Almost all.
99 point.
Yeah.
Oh, yeah.
99.7, that is true. But the book likes to say almost all.
Gotcha.
But we know it is 99.7. What about between 1 standard deviation?
68%.
Okay. So this is actually a nice little review of when you did the empirical rule earlier. Roughly, what percentage of z-scores are more than 0? So how much is from 0 and above?
50.
50%, because that's half of our data.
Mhm.
So D is D, which is 50%. And E, how much is between 1 and 2?
That'd be
13.5.
It is 13.5. Because what you're going to do up here,
68 divided by 4.
say it again.
One number is divided. Hold on, let me figure.
Yeah, but it's not 68 divided by 4. These are not equal areas.
Oh, yeah.
Okay.
Yeah.
So what you would do is you would take 95, because that represents the full length here, and subtract out the 68.
Yeah.
So 95 minus 68 gives you 27%. Now that 27% makes up both of these areas right here. And they have to be the same. So if you take 27 divided by 2, that's your 13.5. So this is 13.5 and this is 13.5. Okay? Again, that question right there should have been all review. And this is coming from 6.2 now. So 14. All right. So we've got quite a few pieces here. It says answer A through G. So it says the quantitative scores on a test are approximately normally distributed with a mean of 50 and a standard deviation of 100. Okay. If I remember right, this is where we got our Greek letters of mu and all that, correct? You think? Maybe not. No, this is not. Joking. So we've got a mean X bar of 50 and a standard deviation S of 100.
500.
Oh, yeah, mean 500, X bar, and standard deviation 100. Okay? So they have put these into z-scores. They are using the normal distribution. Okay? So they want us to answer some questions. All right. So when you do this one, you actually have a couple different ways that we can attack this. So part A is all about making your graph. All right. So let's make our graph. So that's what part A is all about. So they had 0, and then they had 1 and 2 and the -3. And usually when I did this, I always put my numbers above. Who goes right here in the middle?
500.
500. Because that's where the mean is at.
Yes.
How do I get to 1 standard deviation?
plus 100.
plus 100. So how much is this guy right here?
600,
Yay. How much is this one right there?
700,
7,
Yay. And right here?
800,
Okay. One standard deviation below?
400,
Two below?
300.
300, 200.
And then 200. So they want to know on part A, which one matches this picture?
C.
C. Fabulous. And now all we're going to do is we're going to answer questions. Okay? So they want to know roughly what percentage of students scored more than 500.
50%.
Yeah, you got it. So we want to be greater than 500. And so that happens right here. Here's 500, and we want all this, which we know to be 50%. So what they're asking us in this is we're really using that empirical rule to help us out. And it is multiple choice, so that was D. I need to put that on there. So I don't have to flip back and forth. I'm going to write some of these down. So we want to be between, on the next one, between 400 and 600. And we'll get to that. And D, they want us to be more than 800. So greater than 800. E, they want us to be less than 200. F, they want us to be between 300 and 700. And 700. And G, they want us to be between 700 and 800. Okay. So I've got these written down. We can now answer lots of questions. Let me move some stuff up. So when you're between 400 and 600, that's one standard deviation. How much is that?
68%.
Yep, you're just using those empirical rules that we talked about a second ago, 68%. And we'll figure out what letter that is here in a couple minutes. When you're greater than 800,
0.
yeah, that's almost 0. 0%. If I remember right, I think it is 0.15. I think it's 0.15.
Wouldn't
Yeah.
it be 0.015?
Yes.
Wait, no, I may be wrong on that.
Hold on. I'm thinking real quick. 99.7 minus 100. So divide that by
0.15,
2.
yeah.
Yeah, 0.15.
My bad.
Nope, you're good. So almost 0. All right. Now when we are less than 200, so we're down here and we're less.
Almost 0 also.
Yeah, almost 0 again. Because again, this is 0.15. Between 300 and 700, so that's 2 standard deviations.
95%.
95%. And then last but not least, between 700 and 800. 700 and 800. How much? 2.5? No.
34.
Say that again, Miriam.
34.
34%? No.
2.35.
2.35. Okay. Reason being, all right, so when you're right here, to figure this guy out, from -3 to +3, that's 99.7. Subtract out the 95% in the middle. That gives you 4.7. So this little sliver and this sliver give you 4.7. Cut that in half and you get 2.35. All right, so let's go find out what the letters for these were. So you guys told me on C that it was 68, so that's D. On D, you said that it was almost 0, so that was B. On E, you said it was almost 0 or about 0, so that was B as well. Probably should call this about 0, not almost 0. Just fixing my two answers real quick. So about 0. On F, you said that it was 95%, so that's C. And then the next guy, so according to the multiple choice, yeah, they'd say it's 2.5. That's fine. The real number is 2.35, but we'll call it 2.5. And that would be B. And there we go. Just a little bit of empirical rule. Nothing that you haven't done before, which is great. Easy points right there. 15. All right, so we've got an IQ scores have a population mean of 100 and a population standard deviation of 15. There are approximately normal, which is great. We like approximately normal. Okay, and in here, oh, we did learn about mu and sigma in here. We did in 6.2. Perfect. That's what I thought. All right. So we know that mu, which is the mean, is 100, and sigma is 15. Okay, so we use StatCrunch, and they want to find what is the probability when the IQ is 95 or above. So probability when the P is above 95. All right. So which one of these has the correct information?
Figure A.
Figure A? Absolutely. Because you can see right here, whenever you are above, that means you should be shading to the right. Okay? And obviously you see the greater than symbol there. Okay? So it's definitely figure A for part A. Okay. Now part B, it says tell us the probability and round to 4 decimal places.
0.6306.
So 0.6306. I love it. And there you go. Okay. 16. Moving on. We got this. So 2 parts again. So it says use technology to find the indicated curve under the normal curve. Include the appropriate sketch of the normal curve and the graph. So we want which graph shows the area in the standard normal curve to the left of 1.19. Which graph is it?
A.
Yep. Because remember, 0 is right in the middle of this. So it definitely is A. Okay. Part B. Oh, sorry. And it actually says, what is the area? So we're going to need to use some technology here. Okay. So graphing calculator. Where do I go to do normal distributions?
Second vars.
Second vars. Okay. And which one do we do?
Normal CDF.
Normal CDF. Perfect. Okay. So we want to be to the left, right? Yes. Good. So we're going to need to take this 1E99 and make it a negative 1E99. So negative 1. Your E button is right here above the comma. So hit second, comma, 99. And then our upper value was the 1.19. And then everything else is good because it's standard normal. Make sure that it was 1.19. Yep. And you come down and you hit paste. And then hit enter. And there is the probability. It said round to 4 decimals, right? Yep, 4 decimals.
0.8830.
Yep, 0.883, and I would actually tack on the 0 to it. So 0.8830. All right. Part B says, which shows the area to the right?
Can we do it on Star Crunch too?
Oh, Stack Crunch. Yes, yes, yes. Almost forgot. Let's do Stack Crunch for the one down below here. Or did you want to see it on that one?
The first one.
Okay, let's do
This
Stack
one.
Crunch on it. Yeah.
It doesn't matter. I mean, yeah, they're both the same.
Yeah, no worries. We can do Stack Crunch. So we want statistics. And we are dealing with, if I remember right, 1 portion, 1 sample. This doesn't seem right. Going to the wrong one.
Calculators, normal.
Calculators. Yeah, normal. I was like, that doesn't seem right. I'm getting it mixed up with what I've been. It's okay. I get it mixed up with what I'm getting ready to record for you guys right now. So here we go. So our mean is 1, our standard deviation is 1, and we want to be less than 1.19. Compute. And there it is. So for this one, this time it wants us to be to the right. Which picture is it down below?
C.
C. Okay. And then all we need to do is find the probability. This is why I like Stack Crunch, because it's so much easier to adjust with Stack Crunch than it is with the calculator. Because with the calculator, I have to go back in and change up all this information. Well, actually, at least the first 2 pieces here. I have to put 1.19 here, and then I need to make this a positive 1E99. Where if I just go to Stack Crunch, all I have to do is change this. 1 piece. Change it to greater than. And there's my probability.
And how would you get that graph in Stack Crunch again?
Okay.
If you don't mind.
No worries. So let's just delete this guy out there. Delete. Go to Stat, Calculators.
Mm-hmm.
And then you're dealing with normal.
Okay. Stat calculators normal.
Mm-hmm. And then you put in your mean, you put in your standard deviation. Since we're normal, we don't have to mess with that. And then all you do is you pick whether you are below or above, and then you put in that z-score, 1.19.
Awesome. Thank you.
Yep. 4 decimals. What do we got?
1170.
Yay. So good. And that's basically what's going to happen at the end of this exam. I mean, you're just going to keep doing more of these problems over and over and over again, as you can see. All right, so let's jump back to number 17. Number 17, it says, assume that adults have ice cream IQ scores that are normally distributed with a mean of 100. So there's our mu. And that's what this symbol is right here. This is the Greek symbol mu. And a standard deviation of 15. And this is the Greek symbol sigma, if you didn't know that. So they want us to find the probability that the randomly selected adult has an IQ less than 130. So we want the probability that we are less than 130. Okay? So that's roughly what we're looking at. Okay? So again, you got two ways that you can do this. Go into your calculator. This is going to be the last time I do the 84. We do second bars, and we want the CDF. So we want to be less than 130. So is this good right here? The -1 E99?
Mm-hmm.
Yeah, that's good. What's our upper?
Would that be 2?
Why not just 130?
Oh, is that asking for Z-score or?
Well, that's what's cool about this is you don't have to convert them to Z-scores if you don't want to.
Mm-hmm.
So
Oh, as long as you give the mean and...
as long as you give the mean, which is
Okay.
100, and the standard deviation, which is 15, and hit paste. There's your probability. Which is how much? I think, again, it wants 4 decimal places. Let's double check. 4 decimal places. And it is probability, not a percentage. So what's our probability?
Percentage or for decimal?
Decimal.
0.9772.
Yay. There you go. In StatCrunch, you can do the same thing. You don't have to convert these into the Z-scores if you don't want to. So you can put 100. You could put the 15. And we want to be less than 130. And there's what your picture would look like.
StatCrunch is easy.
Yeah, I like StatCrunch a lot. That's how I like to deal with these. But again, though, you can do this problem. So this is what we did. We can work it like this, but you can make it so that it is normal, where the mu is 1. Sorry, the mu is 0. That's your mean. Sigma is 1, and then you convert the 130 into your Z-score.
Oh, okay.
Okay?
Oh, well, yeah, no, I see what you're saying. It'd definitely be easier to just put the regular mean and standard deviation in.
Yeah, see, doing this part where you convert this guy into the Z-score, you got to do a little bit of extra steps.
Mm-hmm.
Not a lot, but just a little bit. So to get the Z-score, all you're going to do is take 130 minus the 100 and divide it by 15, which I believe you said earlier was correct. It is 2. So now you can go back and you can run the same thing again, and you're going to get the same answer. So that's to get your Z-score, which is just your value minus the mu divided by sigma. And again, you can go back and then we can plug this in. Oh, no, I don't want to go to the calculator. I want to go to this. So I can put this back at 0, put this guy back at 1, change this to 2. Same answer. Same picture. All that they changed in the picture before was these were numbers. Same picture. So it's actually your call on how you want to do this piece down here. Because if we know that it is normally distributed, then we know that we can just work with these numbers as is. Or if you really want to change it to the z-scores, you can and work with it as the normal distribution. Pretty cool. It's kind of like dealer's choice. All right, 18. Part A. So they want to know which one of these graphs down below helps us get the probability that a baby will have a length of 19.2 inches or more. Oh, but look down here. These are in terms of z-scores, so they're going to make you work a little bit. So if we read up above, it says the average length of the newborn baby is 18.7. So that's your mu. With a standard deviation of 0.5. So we want the probability that we are greater than or equal to 19.2.
Graph B.
Say it again.
B.
Graph B. Seems right. Because, if we're kind of reasoning this out, 19.2 is above the mean, right?
Yeah.
So that means it would have a z-score above the mean. Okay, and we want to be more, so that's to the right. So these are the only two graphs that are to the right, and reasoning things out, definitely graph B. But if you also think about this too, again, just like what we did a moment ago, this is the information we know. We can convert this into normal by taking 19.2 minus 18.7 and dividing by 0.5, which I believe gives us 1 is the z-score. And so you are correct that the answer graph part is B. Now, what is the probability?
Would that be 0.84?
0.84?
Oh, wait, sorry.
Careful.
I did the opposite one. 0.16.
0.16? Well, let's double check. We can go in here, 0, 1, change that to a 1, but we want to be greater than. So you said 0.16?
Mm-hmm.
Okay. Let's make sure, is it 3 decimals though?
3.
3 decimals. So what does it give us now?
The 159. 0.159.
0.159. There we go. Okay. All right. Part B. Which one shows us how to get the probability of having 19.8 or more?
D.
D?
Mhm.
So, sorry, losing track of which one I'm on here. 18. We're on part B. So you said D? Okay.
Yes.
I like it. And again, you could take that 19.8, subtract it from 19.7. Sorry, 18.7, right? 18.7. Almost messed that up. And divide it by 0.5. And that will give you your z-score. Which, what is that z-score? Let's figure that out. 19.8 divided, or minus
2.2.
2.2? Yeah. So definitely is the graph D, because we want to be above more. So what is the decimal place? Do you need me to bring it up on StatCrunch, or do you guys got this? 3 decimals. What's the probability?
What's the number again?
Say it again.
What's the number? The result?
You don't. Are you asking for the probability or what our numbers were?
Yeah. What did you find?
Oh, that's what I'm asking you guys.
So we don't have to put it on StatCrunch. Just
You could use your calculator. You could use StatCrunch if you have access to it right now. But what is our probability to 3 decimals? I just kept it normal. What'd you guys get?
I'm getting on StatCrunch right now.
Okay. So I'll just give this one to you while you're logging in. So 3 decimal places. What do we got?
0.014.
There you go. 0.014. And again, you can use the 18.7 and the 0.5 in here, and then put in the 19.8. Same picture. Okay? Just using the data on this one instead of the normal. Your call. Oops, wrong one. All right, part C. So this time it says, what is the probability that a baby will have a length between 18 and 19.4? So which picture up here represents, or actually down here, represents the between? Which one?
A.
A, no.
Oh no. Yeah.
That'd be B.
It is B. You're between. So you're stuck between the two numbers. So you shouldn't be outside them. You should be between them. Does that make sense?
Mm-hmm.
The shading should happen between the two numbers. It should look like one lump. You shouldn't have 2 tails. Okay? No 2 sides. It's either one side or the other side, or it's between. Does that make sense, Miriam?
Yeah.
Okay, no worries. And again, you could use the data. Obviously, let's do the between. Let's run it on the calculator so you know what's going on. So second vars, normal CDF. Who do you put in for the lower?
Negative.
Say it again.
I don't know. I've been using StatCrunch for the homework. Seems so much easier.
It's okay. And I'll show StatCrunch too. So what's our lower value? What are we between? What's the lowest?
18.
18. So just put 18. What's the upper?
19.
19.4. Okay. Our mu is still the same, 18.7. Our standard deviation, still 0.5. Hit paste. And what is it? Let's see here. They say give it to me as 3 decimals.
.838.
You got it. 0.838. Yeah, I do use StatCrunch more than what I use this stuff because I think StatCrunch, you just get more bang for your buck. If you converted these into z-scores, 18 is negative 1.4, And 19.4 is a positive 1.4. So if you're doing the normal, you could use those two numbers. So go back in here, scroll down to this guy. So this would be negative 1.4. This guy would be positive 1.4. Your mu is 0. Standard deviation 1. Same answer. Stat crunch. So you're between. So you need to select between. And then you put in your information. So since we have the mean and standard deviation in, we'll put in the 18 and the 19.4 and compute. And there you go. Same information. Or again, you could do this in normal. 0, 1, negative 1.4, positive 1.4. Same information. Okay? Any questions on number 18?
No.
All right, almost done. And I know this took us about 2 hours, but really it will be faster than that because I spent a lot of time showing you some calculator stuff. And I also spent a lot of time writing everything down. So it's much faster than this. So it says in a certain state, the recent average critical reading standardized test score was 540. So there's our mu. Assume that the standard deviation, there's our sigma, is 50. The standardized test scores are normal. Cool. So again, they want to know the following information. And there's only 2 of these. Good. All right. So they want to know for part A, what is the probability? And this time, notice it says percentage. So this one we will write as percentages. So keep an eye on that. Also, if you look right down here by the blank, it has a percent sign. We want the probability to be less than or equal to 550. Okay? So you just go to your calculator or StatCrunch and run it. Which picture is this one going to be, though? Let's get that first. Which picture is this one representative of?
Is that going to be B?
You got it. Because again, this number is bigger than the mean, so I need a line that is above the mean. And since we are less than, we're going to shade to the left. So definitely B. And if you go to your StatCrunch, what do you get? Hopefully you guys got that up now.
Yes. Would that be 0.5? How many decimals, or does it need a percentage?
It's going to be a percentage, and it says 1 decimal place.
57.9%.
Yay. Absolutely. There you go. Because again, you go to your StatCrunch, however you want to run it, because again, you can find the z-score for it by taking 550 minus 540, divide that by 50. What is that? I think that's 0.2. I should get 10 divided by 50. 0.2. So just writing some stuff down. So if we come up in here, go to standard, and we put in the 540, then we put in the 50. We want to be less than 550. Boom. There's what you got. Okay. So part B, what percentage of standardized test takers scored less than 540?
Would that be D?
So the graph is D. Perfect.
And if we had a percentage, that'd be
What is that percentage?
50%.
You got it. 50.0%. Because it's half. All right. There we go. One more. Here it is. Last one, number 20. So it says a study of a population showed that male body temperatures are approximately normally distributed with a mean, so there's our mu, of 98.3 and has a standard deviation of 0.7. So 0.70. What body temperature does the male have if he is at the 80th percentile? Draw and label a sketch. So they are having us reverse this. This percentile, that's your percentage. Okay? Does that make sense?
Mm-hmm.
So we are reversing this. Let's talk about how we do this on the calculator. Okay? So 80th percentile. If you hit second and vars, where are we going to go now? We are reversing this, or another word for reverse is inverse. Where are we going to go? Come on.
Variations?
I'm in second variations. I'm already there. Which one do I want?
I'm not too sure. I've got a TI Inspire.
You want inverse norm. Should be number 3. Look for inverse norm. That means you're going to reverse it. So you're going to hit enter. And then now all you have to do is put in the information. The area, again, this is a percentile, so it's got to be a decimal. So what's the area?
0.8.
0.8. Okay. And then you put in your other piece of information, which is our mu, which is 98.3. Put in your standard deviation of 0.7. Keep it left and say paste. And what is the temperature? And let's make sure that we round correctly. It says round to 1 decimal place.
98.9.
9. Perfect. And that's how you reverse it on the calculator. On StatCrunch, it's even easier. So StatCrunch, put in your mean, 98.3. Put in your standard deviation, 0.70. Make sure that this is less than. And then instead of putting the number in the blank, you're going to put the number in after the equal sign, which is 0.8. And then hit compute. And there it is. And there you go. That's it. And then part B says, which picture is it? So here's the picture. Which picture down here represents it?
D.
D. You got it. Remember, percentiles, that's how I know it's left. Percentiles are always about those that are at this or below.
Mm-hmm.
Okay? So that's percentiles always deal with the left. Okay?
Okay.
And that right there is your exam.
Awesome.
I'm going to go back through and double check those problems on 4.1 through 4.2 and all that stuff. And I'm going to mark it on the answer key, which ones were which. But I mean, really, if you know 4.1, 4.2, and 4.3, you're good. You're good. Okay? Any other questions, Cole or Miriam?
Nope, I think I'm good.
Okay.
Then I have a question about the homework. Can I ask
all right,
you
hold
this
on.
time or different meeting?
Hold on. Not about the homework here. This is
Okay.
about the exam. Okay, everyone good?
Mm-hmm.
All
Yes.
right. So I'm going to pause the video.